That essentially was expanding. Now we go back the other way, factorising. Always look for a common factor first. It's the easiest factorisation that can be done, but the most often forgotten factorisation to be done. Then, let the number of terms in what you're trying to factorise dictate the technique you look for. If it's only got 2 terms, then, well, if it's not a common factor, am I looking at the difference of 2 squares? That would have ended up with 2 terms. Is it the sum and difference of 2 cubes? That could also create 2 terms. If it's got 3 terms, well, the most common thing I see with 3 terms are those quadratics. Is it a quadratic trinomial? Can I look at it that way? If it's got 4 terms, whoa, is it a mixture of things? But probably I'm going to group them in pairs. Just look at 2 of them, do that. Look at another 2, do that. See what happens. So that's the sort of idea process, or thought process, I should be going through. So, all right, this is going to be a great example. Common factor. But basically factorising simply means dividing by the common factor. So if you have something like this, what is it? X. Essentially, I am dividing by X. So if I divide by X, the answer is left in the parentheses, A plus B. That's factorisation. I did this one to bring out the look for the common factor. We see the X, but we sometimes forget the 5. Or we see the 5, but we sometimes forget the X. So we do both of them, 5X. And if I divide by 5X, I get X minus 2. 4 terms. Why is it in common factor? 4 terms. Grouping in pairs often is simply common factors. Because when you look at it, you go, oh yeah, common factor I'm looking for. X's. X, oh damn, it's only in 2. M, oh damn, it's only in 2. N, it's only in 2. Y, oh geez, it's only in 2. So we group it in pairs then, if it's only in 2. So let's do it in pairs. Now, the key to grouping in pairs is the factor that you're left with, you want to be the same thing. That's why I took out a negative y here rather than a positive y. I've ended up with the same thing, because now I don't see this as 4 things, I see it as 2. And those 2 things have a common factor, m minus n. So I pull it out. But it's division. I'm dividing by m minus n. So what am I left with? I'm left with x minus y. Okay, difference of 2 squares. Remember? I'm just going back the other way. So if I see a squared minus b squared, a minus b, a plus b. 16x squared minus 1. Well, 4x minus 1, 4x plus 1. 3, oh no! 3's not a perfect square. 75's not a perfect square. Always look for the common factor first. 3's in both of them. Oh, look what I'm left with. They are both perfect squares. Y minus 5, y plus 5. 5x minus, another grouping in pairs question, not immediately obvious. But let's do it. The first one, if I pull out a common factor of 5, but the second one, those pairs, difference of 2 squares. Common factor, x minus y. I'm dividing by x minus y, so I'm left with 5 plus x plus y. Quadratic trinomial. Monics are always the easiest one. Monic simply means the leading coefficient, or the coefficient of the term with the highest power is 1. But this is the basic idea. You see, when I factorise it, I will end up with something like x plus a, x minus b. If I was to expand that out, that's what I get. And this is why it's been drilled into us. We're looking for numbers, what multiplies together to give, what adds together to give. That's why. What multiplies together to give 18, adds together to give 9? 6 and 3. There's my answer. What multiplies together to give 3, adds together to give negative 4. Now, use logic. In this one, they're multiplying to give a positive number, but they're adding to give a negative number. Got to be 2 negative numbers we're looking for. So in this case, it's negative 3 and negative 1. Again, don't worry about the x and y. They'll sort themselves out. But theoretically, we're saying what's multiplying to give 4y squared and what adds together to give minus 5y. You see, you've got different pronumerals there. But just think of one of them as the pronumeral of the factorisation. In this case, I'm saying this is in terms of x. So the y becomes like a constant number. So what multiplies together to give 4y squared, adds together to give negative. So again, I'm looking for 2 negatives. So it must be x, negative y, x, negative 4y. Splitting the middle. This is great for when the coefficient's not 1. Now, a lot of you probably learned this method called the cross method You know, the cross method of doing these factorisations? You may have seen it. I prefer splitting the middle because it uses the same thought process as the mnemonic ones. Because here I say, what multiplies together to give, but this is where we've got to be careful. In this one, we multiply the constant by the coefficient of x squared. So it's not what multiplies together to give -7, but what multiplies to give -21. Still adds to give the middle one though. Positive, two negative, I'm looking for two negatives, but I physically split that middle term into those two numbers, -3x plus 7x. It becomes a grouping in pairs question now. Grouping in pairs, common factor of 3x in the first one, common factor of 7. They both got x minus 1. I've got the factorisation. There it is. So it uses the same idea of what we're used to with those simple quadratics. Try this one. What multiplies together to give -24 adds together to give -5. In this case, again, use your logic, multiplies to give a negative number. Well, one's got to be positive, one's got to be negative. Adds to give -5, well, in that case, the negative number has to be the bigger number. Okay, so now let's think of this 8 and 3. Yeah, so -8 plus 3. Group it in pairs, and there's our answer. There's that one.